Is my screen visible?
Yeah, it is. Yeah, let me reshare the link again. Yeah. This link in my distance somewhere. Okay. Yeah, I said them again.
All right, thanks.
Mhm.
All right. Okay. Um.
Wait, who is keeping the time? I elect Prince to keep the time.
All right. Can I commence? I
Yeah,
should read
you
the
can
question.
comment.
Okay. All right.
You want me to read
So
for you?
yeah, you can read it, please. Or make me read it. I like
Yeah,
to read
read
it.
them, read them.
All right. So design a payments gateway service similar to Stripe that lets merchants, example, e-commerce sites like Amazon, accept online payments from their customers using credit and debit cards. The system must reliably move money from the customer's card to the merchant's account. Handle failures gracefully and operate at scale. You will integrate with an external payment service provider or acquire for the actual card network communication. You are not building the card network yourself. That's good to know. So functional requirements here are the merchants can initiate a payment request to charge a customer for a specific amount. The customers can pay using credits, debit cards, mobile money is optional. Merchants can view real-time payment status, pending, succeeded, failed. A merchant can issue a full or partial refund. Customers can save payment methods for future use. Organization. Okay. Non-functional requirements means scale 10,000 transactions per second at peak, reliable, exactly once semantics, no lost or duplicated charges, consistency, strong financial integrity, money cannot be miscounted even under partial failures, security and compliance, PCI DSS compliance, raw card numbers must never touch your service. Interesting. Latency P99 payment authorization should be, so the worst experience should be 30 seconds. Okay. Okay. Let me make this bigger. So we are designing a payment gateway specifically for credit and debit card payments, with mobile money being optional. Now, we are a gateway service, meaning we are going to provide services to merchants, as in businesses, who are going to be accepting payment through the our service or our system. Now, for that reason, we will have to design this in a way that we are serving actual businesses and not just look at it from the standpoint of allowing payments or money movements. We have to account for the fact that every request to send money is in relation to a merchant, which means we have to handle, or we have to have a way to relate operations in our system to the particular merchants which it was initiated for, right? So first of all, I would want to start with identifying a way of identifying merchants in our system, right? Before we move to the functionality of allowing them to take money. So for something like this, we would have to have a way of keeping or recognizing merchants on our system. So we could have a service. I don't know what we'll call it, but we could have a what do we call it? Um, a kind of storage or database for our merchants, right? For the businesses. So we call it merchant. Struggling with the name, but we could call something. We call something like a merchant info store, which would hold vital information like obviously the merchant name, um, the kind of fee structure on the merchants for the kind of fee structure on the merchants, depending on whatever payment channel. We could also store something like what kind of relevant information do we need here? We could hold information here like the merchant's settlement accounts, where they hold the money that they've received payments from customers, where we'll settle that money into. And I'll fill out some of the information later. But the whole idea is we have a store where we hold merchants' information, right? We could also let me add things like for authentication, maybe uh, their API keys, something. What else do we need here? ID, some merchant's ID, yes, there are. So this, let me put something here and call it merchants info service. All right, so this service here is going to like help us identify our merchants or hold like specific information to the merchants. And with this, we can go ahead and start designing the system. Once we have a way to sign up merchants onto the system and like have them onboarded. So we're able to identify each merchant in our system, the information attached to them and stuff. Now, in designing a payment gateway that accepts, that allows a credit card payments and stuff, first of all, we'd have to have backend services that integrate with payment service provided, card payment service provided. But as the question already pointed out, the network or it assumes that the network and the integration part is already sorted out. So we're going to have, let me use this thing to represent, okay, no. We're going to have, sorry, we're going to have this represent the whole payment service, external payment service providers. Yeah. Sure. All right. So here is going to be inclusive of the card gateway, the network, our card acquirer system, etc. All right, everything here. This is where we go to when we want to initiate the whole process of money movements and all this kind of stuff. All right. So this is here, and then we're going to have something to represent our actual application, a service that proxying the request or actually making the request to the external gateway. So this keep forgetting to uh, yeah, okay. Yeah, and then we would have our application server also here like this. Let me start mapping the thing here. So let's start mapping it out. So we're going to first design the we're first going to design the interaction from the UI standpoint, as in if we have exposed APIs to our merchants or a UI or whatever means of initiating card transactions, card debits, or whatever it is, the request is going to come to our application service, and application servers are going to like interact with card service providers, right? We're going to start with that. Now, obviously, there are going to be like other services involved in this. So we're going to like look at that data, but I first want to map out the initial communication pattern between like the most basic form before we add anything to it. That's why I'm not drawing out everything just instantly. What am I doing? I want to make this smaller. So this will be our UI clients.
Well, just to note, you shouldn't be restricted to Excalibur. If you are comfortable with any other tool, you can use that.
No, okay, here.
Just to point out. Yeah.
All right. Yeah. Yeah. Our UI clients or whatever we expose here. All right. Yeah. So this would be a requested application server. Christ, what am I doing? And then that will go here. Okay. I think I got the hang of it now. I think I can just use the numbers. So that will go here. But mostly when you are designing a system like this involved like especially with card payments or most payments channels, is rarely synchronous. The external gateways mostly have to communicate states to you or communicate to you like the next decision on what you have to do asynchronously. And hence we would have to introduce a service that would listen for the async communication, and then we'll continue like with the flow. All right. So it's something like a credit card or debit card payments. The basic idea is that when you want to do a credit card payment, normally, if most of us have experienced it before, when you initiate a card, when you're trying to pay with card on the gateway, it's two things. Either you are being presented with a challenge screen, which is um, like an extra layer of security to verify that you are actually the owner of the card, or sometimes you don't experience that at all, and then it just goes on to debit your account. Now, we are going to design the system to take account the 3DS, what they call the 3D secure flow, which is like the extra verification step I spoke about. And in that scenario, there is going to be, like I said, a communication from your external payment gateway, whether you should proceed or not, or whether like they've done risk assessments and everything is fine, right? So there's going to be initial communication, like I said, from UI to your server will go here. And before there is an actual request. So you can label this initial request or initiates. I want to initiate request here. So when we do an initiate request, we get a response back, which kind of informs us what our next action would be. In a typical card payment operation, it's normally two requests that you make. Make the initiate request, you get a response. The response is like it involves like information whether is the card number correct and all those kind of stuff. If everything is fine, they've done like an initial surface check, right? And then you make another request called the authenticate request. Now this is like the actual request that initiates the whole flow. When I say the whole flow, now, like I said, in this system that I'm designing, I want to take into account the 3D secure flow, as in we want, if where possible or where needed, we want to like employ the whole extra security layer check where you get presented with a screen from your this one your issuer, whatever bank you are using, where you verify with them either via OTP or whatever verification this one before like your account is actually charged. All right. So on the second API call authenticate request, when we hit it, there's two things. They are going to the response that comes back. Let me just put this one here. The response that comes back tells us whether we should present to you the challenge screen or it's fine, like based on their checks, based on your device, your location, everything is fine, and it's like okay for us to just charge your card instantly without like doing all that, right? So authenticate response extra authentication needed, everything fine. Frictionless. Okay. So this is where we are currently, and the idea, like I was saying, is UI makes requests to our application server here. Application server hits our external card payment service provider. This is the initial phase of the whole card transaction. Now, if we hit the authenticate request and it says, oh, everything is fine, everything is okay, or something like that, we will just proceed to charge the card. But if the response comes back and says, oh, it needs extra authentication, UI proceeds to render a challenge screen, or like they have a way of inserting the whole screen to you where you interact with your bank's like iframe or whatever it is. Now, when that communication is done, the response or the communication to us is asynchronous. So we'll have to have something like a callback API. All right, so I'll just put a callback API somewhere here. Where should I put this? API here. Callback API here. This callback API here, we receive callback from our external card PSP here. So how do I draw this? So I could have, I would want to shift this away. Oh. Right. All right, so we could just draw something like this. So this would be the callback on authentication status. So when we get a callback on the authentication status, after the user is done interacting with the challenge screen or whatever it is, we get the verdict here, whether it is fine, we should proceed, the person entered the right OTP or whatever. Then from here, we could go ahead and hit the payment service provider again to actually charge the card. request charge with everything process. Or let me add this here. Or field request and flow. All right. So now that we have the basic structure out of the way, I like to like fill the other stuff in while like attending to the functional and other non-functional requirements, right? All right. So merchants can initiate payment requests to charge customer for specific amount. Now, in a system like this, is with the whole how it involves asynchronous communication and stuff, there is like intermediate states preservation and continuing on all those kind of stuff, right? So we will have to like employ several services to aid out with that. But first of all, one of the most some of the most vital like components in our system here are things like our merchant information service here, which gives out information on our service. But one thing that's also very important is a way to represent every transaction that goes on in our system. Every operation here, from the UI to application server to external and a callback or something, it represents one what's the word? Represent one unique transaction or order, right? However we want to identify it by. So when the UI hits our application server, what we want to do first is create a record for that particular transaction, right? And for that, we need like an order service or whatever it is. So we'll have like a transaction service or something, an order service. Basically, this will be responsible for creating a record, persisting it to represent the initial state of the transaction, right? So we have something like that here. Let's put it here. So with every transaction to debit a card, when we hit the initiate request, the application server would make a request to create an order to the order service. Now, some of the like relevant information here could be something like the ID, ID of the order, the ID of the order, the amount, the status, sorry, which always starts with unpaid or pending, something as the initial status of the order, and some relevant information like correlation ID, whatever it is. Like whatever it is that we want to do, picturing this, right? A record. Where do we keep this record? We would store this record in, we could use something like Elasticsearch to hold the record. All right. So this will just be our ES resource that this thing will be creating this one in. Just something simple. What am I doing, bro? All right. I just want to create this one. An arrow. Something like this. So we have an order service. So now for every initiate request, the application server would create a record, which is this, right? And it's fine for us to maybe after we get a call back, try to look for the order and all those kind of stuff. But I don't want to do that. So I want something like a fast retrieval layer. So maybe we could use a cache storage like Redis or something. All right. Now, the reason why we are using Redis is when we create the order, this is the initial state, this is the initial record of the order, right? Which will eventually get updated after the whole transaction is done. But in between that happening and the callback API and all those kind of stuff, there is a way, since like these two operations are decoupled, when you're having a callback come, you have to have a way to continue from where you left off. And I don't want to overload the ES or like go to I want to decouple the creating of initial transaction records from API calls to ES just to get data to continue the transaction, the transaction or the charge of the card. It's not, it's better if that load or that like request, those type of requests are not like, we don't load the ES with that. It's very unnecessary, since we don't really need much to even continue like with the charging of the card. So guys, how do I? Okay, so we would also have a Redis instance here, right? Just some quick Redis to help us hold some states. Now, when will we use the Redis? Just like how when the customer or wherever the request is coming from to debit somebody's card, we create an initial record here. After the authenticate payer request, or even during the authenticate payer request, right? Where we know that after the initiate, like I said, initiates has some initial checks which prove whether we should go on with the transaction or not, right? So on the authenticate request here, when we know that, okay, this is actually a transaction that we are going to do, we could also store some relevant information here. Now, I keep forgetting it, but the initiate request here, like he said, it comes with relevant information like the customer's card details and all those kind of stuff. And in the non-fact, I'm coming, sorry. What's happening? Actually, Nana is, I don't know, this one is messing up. I'm trying to type.
I
Am I
think try
audible?
double clicking. What are you trying to type?
Like I'm trying to
Why are
use
you trying the text?
the test.
Let me try my mind. It works for me.
Okay,
It
it's
works
fine.
fine for me.
All right. So when the initial request comes in, get something like card number, CVV, expiry information, amount, and all those kind of stuff. All the information needed to satisfy the request, right? So there's this kind of information that we will store. When this information comes, now because it's two requests and then they all related to the same transaction. On this first request here, if we get like a positive response from the external service provider, what we can do is, while we create the order or we create the initial transaction record, we could also persist all the details that the request came with in the initial this one via the initial request to Redis. All right. So in addition to this, just got guys, pardon this one. I'm really terrible at this. So here, we would also like cache request information, like some of the information that I've listed there, right? Right. And the reason why this is relevant is that when we have this information in cache and after the authenticate payer request, and in order to continue the transaction like asynchronously, when the callback comes to the callback API, we remember here, we make a request to charge the card if everything is fine or whatever. Now, if everything is fine, at this point, all we have is like an ID that the payment service provider is probably going to return to us. And in this case, and this callback API, this callback service here, we retrieve that information from cache using that ID and then use that details, which is the card and this one, to charge the card. When normally the request is an API, it's an API request, so it's synchronous. So when we get a response back, we can update our order service that the status is now paid or successful or is failed or whatever it is. Now give this a final record, a final status, and mark it as like satisfied or whatever it is. So because we are collecting money, I just want to rush like 4 things here. Because we are collecting money after a transaction is successful or whatever it is, we would have to settle money to our merchants. Now it's 2 things. Are we doing it instantly after every order, or we are doing it like in batch? All this will depend on configurations. Now, our service here, like the merchants info, or whatever, this one would allow us to make that decision, right? So we could have configurations here, or when we onboard the merchants, whether they want to be paid on the hour, they want to be paid at the end of the day, or whatever it is. Now, based on that, I don't expect that after the an order is done, let's assume, I'm going to go with the assumption that they want to be paid on the hour, right? Not instantly. We have to settle the money into their accounts, and for that reason, we need another service to do that, right? So we could have like a settlement service. I'll put you here. Can I put you here? We have a settlement service. This is just to deal with that part. Settlement service here. Now, what settlement service here is going to do is it's going to be fetching transactions from our ES on intervals. 1 hour is going to run every 1 hour. Every transaction is within that hour, aggregated, and then make a request to settle the amount into the customer's account in whatever way that we are managing in-house accounts or internal accounts, FINRACs or whatever it is, right? This is not really part of the functional requirements, but to make everything complete or give the whole picture as serving actual businesses, I just added it here. All right. Okay, so I just want to look at the question again, right? So merchants customers pay using credit card and all those kind of stuff. I think this is all fine. Now, one thing we have to look at is the refund scenario. In order to issue refunds, the same thing. We have like exposed endpoints where we have an internal service. I think with refunds, we would have to be able to control that within our system. So we have a service in our system where we would initiate refunds from. But the same scenario applies. We are going to have to expose endpoints or functionality from application servers, communicate with the external payment service provider to actually initiate the refund. All right. I think I'm running down on time, so I just have to address the some of the non-functional requirements, like addressing scale and all those kind of stuff. Now, of course, when we have increase in traffic load or something, this does not scale well, right? Just I'd like to point that out. Now, to address that, if we are having 10,000 transactions per second at peak, we would obviously want to distribute the load, all right? But what we could have is load balancer in front. We could have run multiple instances of our application server and put a load balancer in front of it to distribute the load between it. In terms of the ES, we could rely on infrastructure from cloud service providers, specifically with the features of auto scaling, or those features where they respond to load and then they scale to handle the traffic, right? Because I'm pointing that out because if we allow more requests here via load balancers or application service, we are definitely going to have a choke point if it can't handle that much load, right? So we need something that's elastic. I think that's the word I was looking for. That like expands based on the traffic that is coming in. And same and same for the callback API. Since we are using external states, right? It depends on Redis to fetch the data and continue and all those kind of stuff. We could have multiple instances of our callback API running. And since application servers have multiple APIs, we could configure the different callback APIs, however much we are running, distribute them out in the configurations of the application server. So maybe if the request comes to application server A, it goes through callback API A or something like that, and it continues and then hits this one, updates the record and everything is fine. All right, so that's to address the load. I'm basically trying to say to address the problem of like increased traffic or load, I would use the load balancer, run multiple applications of my server, need an elastic ES storage provision from a cloud provider like AWS or something, which scales or expands or is able to handle load depending on like spikes. Run multiple versions of my callback API and distribute transactions on them. Okay. So in reference to the PCI DSS compliance, what we're going to take importance, we're going to make sure that we store in nowhere in our system do we retain user card info. In the other service or in the ES, every card information that's attached to the transaction record here will be masked. It is it's very important here. In the Redis, obviously, we can't mask it because we can't make transactions with a mask card number. And that is why the requirement here that raw card numbers cannot touch our servers is kind of a problem, right? Because we actually need the card numbers. We would make sure that every login of like card numbers and all those kind of stuff are maxed. We'll make sure that we do not retain any card information in our system. And even if we do, in terms of the Redis, in relation to the Redis, it's temporary. Am I missing anything? No duplicated charges, kind of stuff. Right. Yeah, that's very important. And in order to address that, I think what I would do or what we would put in place is like very good idempotency, right? There are several like hot points where we need to implement idempotency. Most importantly on the callback API. Now we are interacting with an external provider. There's a lot that could go wrong here. Multiple callbacks, delaying, all this kind of stuff, right? So here on the checkpoint where we retrieve the status, we get the status of the authentication from the customer, and then we decide whether to charge the card or not. We have like very good idempotency checks here, of course, relying on Redis to make sure that this transaction has not already been satisfied or we've not already processed this using an ID or something to make sure we don't do duplicate transactions. All right. If we're not using Redis, we could like if it's that bad, we can also check the ES store and check the status on the transaction, whether everything is fine. To make this a little more scalable, one thing that we could do is instead of like an actual callback API here handling all the like the check and then making a request to charge the card, we could bring in consumers, right? And the callback API here, when it receives the request, all it does is just pushes it to a Kafka consumer, produces the Kafka consumer, and then the processing actually happens there. In that way, we queue everything, everything happens eventually, symmetrically, and then we don't like choke things here or something like that. So Nana, I don't know if I missed anything. You can like help me point, help me by pointing it out, especially if I miss
There's
anything
like
on the
5 minutes left.
Okay, so how do we maintain an exactly one semantic? Like, how do we assure there are no lost or duplicated charges? I don't
duplicated
think
charges. When you say duplicated charges, what does that mean?
like we charge we charge a customer more than once. Like a transaction happens exactly once.
We don't, we don't debit somebody 2 times, right? Important.
Yeah, exactly.
So okay. So in order to take money from somebody's accounts via their card, like I said, we would have to initiate a call to the external payment gateway to actually take the person's money. Now, in a situation where there is like double charges and stuff, that means it's two things. Either we made a mistake and then hit the request twice. Like we initiated a request to charge the person's account twice. And how could that happen? In a scenario like this, is either the callback API, the callback API has fired a request twice, or we've received callback communication from the payments gateway 2 times. Like maybe it's a mistake on the status of like the authentication of like the customer, the challenge screen on all that. So that's why I pointed out that in order to make sure that every transaction or every order is satisfied or is processed once, since we have a record, initial record of the transaction, which we are monitoring, right, via the status, we could have an idempotency check here on the callback service or whatever intermediary service where we initiate the request to charge the card. In that way, when we implement an idempotency here, which is like a simple check, right, via an ID or something, we could basically just do it with Redis with a TTL or something, like 1 year or I say 1 year, like 1 month or something like that. So for every request that comes to the callback API, which makes the actual request to charge the card, we check here whether like this ID has passed through here before, right? Like an idempotency check here to make sure that we don't initiate a charge for a transaction, a record of transaction twice. If this is an order that was created to charge somebody 20 Ghana or 25 cedis or something like that, for this order, for this specific unique order ID, we are not initiating request for it 2 times. We should not do that ever. And one way I know to actually like deal with that is to do a simple have I attended to this order before a check, and then like you don't do it again. I don't know whether that answers the question or the like other concerns.
Yeah, it does.
Okay.
Madam Timekeeper, I think time is up, right?
Yeah,
1
so
minute.
one more thing. Yeah,
1
one more
minute.
thing. Mention real-time payment status succeeded field. Like so, yeah, via the other records that are being saved in the ES too. Since we have like the status being appended stuff, like initially it starts with pending succeeded field. Now, via this record could also power something like this, which is like the status of the transaction, right? So like with the check status, we could be going to ES to check the status of the transaction or this or whatever it is, and then point it out. Yeah. So yeah, that's it for me. Thanks.
All right, thank you. Does anyone have any questions for Mr. Gwalisam?